simply going to be looking at binomial expansions. So let's say if you are very familiar with the basic expansion, let's say you have been told to expand, let's say 1 plus x squared. So if you're going to expand this, I'm sure you're simply going to say 1 plus x, close brackets, and then again here 1 plus x, and then what you're simply going to say is 1 times 1, which is 1, 1 times x, which is x, and then now x times 1, which is x times x, which is x squared, and then now you're simply going to say 1 plus 2x plus x squared. Yeah, so this is the basic expansion. But now let's say you have been told to expand the same thing. Let's say you're told to expand that, let's say to the power, let's say this wasn't 2, let's say it was 4. So notice that you have plenty to do, but that's where binomial expansion comes in. So one thing that you have to understand about the binomial expansion is first the elementary Pascal's triangle. So what is Pascal's triangle? So if one thing is basically expanded to the 1 power, let's say wanted to expand a plus b, let me just say x plus b. Let's say if wanted to expand x plus b to the 1 power, it's going to be simply x plus b. Oh, sorry. If wanted to expand this to the 1 power, then the coefficient of x is simply going to be 1. And then let's say wanted to expand the same x, but let's say to the power 2. So then the coefficient of such an expansion would be 1, 2, 1. And then now here's where the trick comes in. Here's where I'll have to apply the simple trick of the binomial expansion. I can write my x properly. X plus b. Let's say I wanted to expand this to the third. So what you're simply going to do is to write a 1, and then you're going to say 1 plus 2, 3, and then here again 2 plus 1, 3, and then at the end basically put in a 1. So that's how Pascal's triangle goes. So let's say I wanted to expand x plus b to the first power. We wanted to find out the coefficients of such an expansion. So we're simply going to have 1, and then we're going to have 1 plus 3, which is 4, 3 plus 3, which is 6, 3 plus 1, which is 4, and then always a binomial expansions always have got the 1 at the last. So then that's how it goes until to the fifth power. So now let's say we wanted to expand something using the binomial theorem. How can we go about such? So let's say we had let's have an example concerning the Pascal's triangle, just to get a feel of things. And just remember those binomial coefficients are going to be they're going to come in handy a lot. So let's say we have been told to expand to, this is in brackets, let's say we have been told to expand 2x minus 1 to the fourth power. So again, you can drop your binomial expansion to know the coefficients that you're going to be using. So you're going to have 1, and then you're going to have 1, 2, 1, 1. Here you're going to have a 3, a 1, a 1, a 4, a 6, a 4, and a 1. So this is raised to your power 4. So then this is your fourth power. So you're simply going to use the coefficients of your fourth power. So I can simply cut this out, and then I'm just going to write my coefficients for the fourth power, which I'm going to use in my expansion, which is 1, 4, 6, 6, 4, 1. 4 1. Now that I've done that, I can go ahead and start my expansion. And then one thing that you also have to understand is that we're going to have ascending and descending orders of powers. So I'm simply going to write my 1, and then I'm going to separate this and say 2x, and then I'm going to write my negative 1, and then I'm going to raise my 2x to the 4th power, and then I'm going to raise my 1 to the 0 power, so that when I say 4 plus 0, I get back my original 4 of the expansion. And then I'm going to do the same and then say plus, my next coefficient is 4, and then I have 2x. So here we're going to be going the ascending powers of x. So my x was raised to the 4th, so now it will be raised to the 3rd, and then my negative 1 will be raised to the 1st power, just like that. And then plus my 6 now, and then I'm going to have 2x raised to, this was the 3rd, so it becomes to the 2nd, and then my negative 1 increases, it was 1, now it becomes 2. So I'm simply going to continue and say plus my 4, 2x. So here 2x was to the 2nd power, so it will become to the 1st power, and then my negative 1 will go to the 3rd power, plus 1, because 1 is my last coefficient, and then 2x. 2x here will be to the 0 power, plus, being multiplied by negative 1 now to the 4th power. Notice that the powers of x were reducing by 1, so here were 4, 3, 2, 1 until we have got a 0, and then this constant value of us, negative 1, was increasing by 1, so here it was 0, 1, 2, 3, 4. Remember, the 0 is always important. Don't forget to put that 0. It's very important at the stage. So now here, when we simplify, we are simply going to have, this will be 16x to the 4th power. That's if we expand that. Binomial expansion is probably learned by people taking pure mathematics or additional mathematics. So such expansions shouldn't be something to take which is going to consume much of our time. So once we expand this, we're going to have a negative 32x to the 3rd, 32x to the 3rd. I'll just read my 32x to the 3rd, and then when we expand that, we're going to have plus 24 x to the 2nd, and then when we expand now here where we have got 1x, when we expand that one, we're simply going to have negative 8x, and then here we're simply going to have negative 1 to the 4th, because this will be raised to the power 1, so anything raised to the power 0 is 1, so then our x will completely go, so we're simply going to have 1, we're going to have the plus 1. Then just like that, we have expanded using Pascal's triangle. So if you have enjoyed a video, please leave a like, subscribe, share with friends, and I'll be seeing you guys in the next video.